If you work with data warehouses, you know we're fantastic at handling structured data. Numbers, dates, categories, no problem. But what about all that valuable insight that's locked away in documents, emails, and reports? Well, in this explainer, we're going to break down how we can move from just storing text to truly understanding and integrating the information that's inside it. Let's get right into it.
So here's our game plan. We're going to start with the classic approach, something called information retrieval, and pretty quickly, we'll see where it hits a wall. Then we'll dive into a much more powerful alternative, information extraction. And finally, we'll look at the tricky part, how to actually integrate that deeper understanding into the systems we already know and use. All right, first things first, let's start with the basics. How do we currently get all that messy text into a nice, orderly data warehouse? Well, the traditional answer comes from a field that's been around for decades. And that field is information retrieval, or IR for short. The best way to think about it is like a library's card catalog or a good old-fashioned book index. Its main job is to point you to the right document based on your search terms. Now, this is incredibly useful for finding sources, don't get me wrong, but its goal is to hand you the entire container, not to tell you about the specific facts swimming around inside it.
The way this is usually set up will probably look familiar to you. To get text into a relational data warehouse, we typically just dump the whole document into a special field, a character large object, or a CLOB. Then, all the structured information about the document, the author, the date, the source, that gets stored in your standard relational tables. What you end up with is a classic star schema, where the text itself sits in the fact table, and all that metadata populates your dimension tables.
So how do we actually search through all this text? We have to rely on keyword-based searches, usually with a familiar SQL predicate like contains. We can tell it, hey, go find me all the documents that mention volatile items and revenue. It's a powerful tool for sure, but at the end of the day, it's just a game of matching words. And that leads us right to our next big question. If keyword searching works, what's the big deal? What's the problem? Why do we need to move beyond just searching for terms? This really gets to the heart of the problem. It's the huge difference between simple term matching and actually understanding the meaning. A keyword search can tell you, yep, the word revenue is in this sales report, but it can't answer the real business questions, can it? Who generated that revenue? How much was it exactly? And when did it happen? You see, IR finds words. What we really need is to find answers. If you look into the hood, the model that IR is built on has some serious technical challenges. It represents documents in this massive vector space, where every single unique word is its own dimension. You can imagine how gigantic and inefficient that gets. But the real critical error it makes is assuming all words are independent. It treats car and automobile as two totally unrelated things, completely missing that semantic connection and, of course, all the context around them.
Now, to be fair, people have come up with some very clever patches to try and work around this. One of the most famous is latent semantic indexing, or LSI. It uses some pretty advanced linear algebra, specifically singular value decomposition, SVD, to figure out which words tend to show up together across a ton of documents. By doing that, it can uncover these latent, or hidden, relationships and start grouping synonyms like car and automobile a little closer together. It's a really smart fix, but it's still just a patch on the original, limited model.
So if keywords and their fancy patches just aren't cutting it, what's the alternative? Well, to really solve this problem, we need a totally different way of thinking. We need to shift our focus from finding documents to extracting structured facts from them.
And that brings us to information extraction, or IE. Unlike information retrieval, which basically treats text as just a big bag of words, IE analyzes the content with a much deeper purpose. Its goal is to identify specific pieces of information, names, dates, events, relationships, and pull them out into a structured format we can actually use. The whole IE process is like a multi-stage pipeline, where each step builds a new layer of understanding. It starts simple. It breaks the text into words. Then it analyzes the grammar, tagging parts of speech. After that, it parses the syntax to figure out the sentence structure. And only then, with all of that valuable context, does it do the final semantic analysis to actually interpret the meaning and pull out the key facts we're looking for.
So, what do you get at the end of all this? Instead of a list of documents, the goal of information extraction is to fill out a structured template. Think of it like filling out a form. It does entity extraction to find things like company names. It performs link extraction to understand how they're related, like company A acquired company B.
And it does event extraction to identify exactly what happened.
This brings us to the final, and let's be honest, the most practical part of all this. We've got this powerful new structured data that we've pulled from our documents. Now what? How do we actually integrate it with the structured data that's already living happily in our warehouse?
It turns out there are two main strategies, and each one has a really clear trade-off. The first approach is to try and stuff this new data into our existing database tables. The pro here is obvious. We can use the SQL and tools we already know. But the major downside is that any bit of information that doesn't fit neatly into a pre-existing column just gets thrown away. It's lost forever. The second strategy is to store the extracted templates separately, maybe in a flexible format like XML. This is great because it preserves all the rich information, but it means we need to figure out new ways to store and query it.
This sentence right here really highlights the challenge. An IE system can understand this. It's comparative, it's contextual information about the price. But think about it. How do you store that in a standard database column that's designed for a single number? You can't. This is exactly the kind of valuable business insight that just gets lost if you go with that first integration strategy.
Ultimately, this is what it all comes down to. Moving from information retrieval to information extraction is really about leveling up our capabilities. It's the difference between treating text like an opaque blob of stuff and treating it like a first-class, queryable source of data. It lets us tap into the rich, contextual knowledge that's been buried in our documents and pull it right into our analysis.
And that kind of leaves us with a final big picture thought. We've spent decades building our data world around the structured, predictable nature of the relational database. But as unstructured data just keeps exploding, we have to start asking ourselves, is that model still the true center of our data universe? Or is it maybe becoming just one important planet in a much larger solar system?
And that's all for this explainer. If you want to keep diving deep into complex topics just like this one and join a whole community of focused learners, be sure to like, share, and subscribe. Thanks for watching.